Lesson 23, question 5, part E. What is the pH at the equivalence point? So when we have a weak and a strong in our titration, this is where essentially, and we're at the equivalence point, the role is going to reverse. The conjugate acid, which was the product, the minor component at the equivalence point, then becomes the dominant component, and therefore is going to be the equilibrium that we need to focus on. Okay, so therefore the conjugate acid becomes the acid, and it's going to react with water, giving back that proton that it got, and it's going to produce ammonia and H3O plus. And so we're going to have a Ka instead of a Kb. So one of the things we're going to have to do is convert our Kb to a Ka, so we can set up this problem. So let's do that part first. So let's take our Kb and divide the Kw by our Kb, 1.8 times 10 to the negative 5th, which gives me 5.6 times 10 to the negative 10th. Now, at the equivalence point, I need to set up an ice table, but I need to know something about my NH4 plus, which is how much I have. And all of the NH4 plus that I have for my ice table, its initial concentration, is going to come directly from the moles of HCl added, okay, divided by the new total volume. So in this case, at the equivalence point, which we determined to be 54 milliliters, I would have added 0.054 moles of HCl because the equivalence point is 54. I started with 0.09 liters of ammonia, and I've added 0.054 liters of HCl. So when I do this problem, it's going to give me a new molarity of 0.375 of ammonium ion. Okay, so I'm going to take that number and plug it into my ice table. I have none of my ammonia, at least at this point, and none of the hydronium at this point, because all of it at the equivalence point is the, we're trying to determine the new pH at the equivalence point. So my equation is going to shift to the right, because my Ka, when it's multiplied by 1,000, is much smaller than the concentration here. So this is much smaller than 0.375. I can go ahead and get rid of that x. So now I'm going to set up my Ka expression, products divided by reactants equal to my Ka value that I just calculated. I should get that x is equal to 0.1234 zeros. So 0.00014 molar. Hopefully that was enough zeros. I'm going to take the negative log of that value to solve for the pH. I would expect that it would be acidic and strongly acidic at that, because I'm adding a strong acid. So the equivalence point should be more heavily towards the acidic side of things than the basic side. Okay? So at the equivalence point, when you have a weak acid, strong base, or a weak base, strong acid, the initial ice table that you start with is going to flip. That equation is now going to go right to left, and so you're going to flip-flop everything to reflect that change. So the last one that we're going to do on this video is what is the pH after 60 milliliters of acid is added. So this is after the equivalence point, because the equivalence point is 54 milliliters. So in this case, I'm going to have excess acid, and I need to know how much. So at this point, I've added 60 milliliters. Because it's a 1 molar solution, the math is pretty easy, because it's just going to be the number of moles we have is equivalent to the volume we've added in liters. And the number of ammonia moles that I started with has not changed because I haven't added any more. So I'm going to take the difference between the two. And this is how many moles of HCl I have excess. Their volumes are going to be totaled to give me 150 milliliters. So I'm going to divide the new number of leftover moles of HCl by the new volume, which is going to give me 0.04 molar. Plug that into pH as the negative log of 0.04, which should give me a pH of 1.4. Now the last part on here says to draw an expected titration curve. So this is going to be pH, and this is volume of HCl added in milliliters. Initial pH was around 12, so starting off probably right about here. And then we know at the equivalence point, which is, let's just say, it's around 50. Okay, so around 50. So a little after that, the equivalence point was, after 50 milliliters of acids added, the pH was 8.16, so just a little bit over the 7. And the equivalence point pH is 4.84, and that was at 54, so not quite to scale. And then after 60 was added, the pH went down to 1.4. Okay. So something like this starts off basic because it's ammonia. Equivalence point is on the acidic side because it's a strong acid, and the pH is going to end up in the acidic range whenever the excess HCl takes over. So this should be all of the videos for lesson 22 and 23, those practice worksheets. So important you can do these problems. The unique thing about being out for a whole week is that you shouldn't have the 3 hours of lab. Hopefully you have some more downtime to study these things because I cannot stress the importance of understanding titrations and buffer problems. If you don't, and you are a chem major or a chem minor, or you have any intention of taking quantitative analysis and you don't know these, you're going to be so lost. And when we do the lab here, not this coming week because we'll be out, but the following week, you will be so lost on those calculations as well. So watch these more than once. They are short videos, and it is worth your time because you will get faster and better at the problems the more time you dedicate to practicing them, which you need that for the test. And so this should cover everything that you are expected to do this week. Make sure you do quizzes and homeworks, and then follow Canvas. And what we'll do is we'll pick up with lesson 24 on the Monday that we return, which would be Monday, March 23rd, which would be chapter 15. Okay, so we're getting close to the next test. Make sure you are keeping up with your material. Even though we're out, we are not on spring break for an extra week.